In this tutorial, we're going to walk you through using the nesting feature in the software to achieve maximum usage of our available material. We take you through several scenarios, each demonstrating how to use the different options and which ones work best dependent on the type of job that you may be running. So let's start by opening a new copy of the software, and let's go to Open an Existing File and navigate to our Projects folder. For our first example, we're going to choose to open the Olympic Stadium.crv file. So just highlight that and click Open. And this is the job that we've been requested to make for our Olympic Stadium signage. So we've got a border and then we've got all the letters for our sign. And we've been asked to create two lots of these signs, and we've got our one piece of material which is 48 inches in width and 48 inches in height. So how do we go about making multiple copies of this using this material that we've been given? So we could manually create multiple copies of the vectors that we've got on screen and then rearrange them all to fit ourselves, or we can use the software's built-in nesting function. So to use this, all we need to do is simply select some vectors. So I'm just going to drag a box around the vectors we've got on screen, and I'm going to come over to the Offset and Layout and select the Nest Selected Objects button. So just click that, and we can then go ahead and specify our options on the form. So the first option that we are asked is the tool diameter, and the tool diameter needs to be the tool that we're going to be using to cut out our shapes. So I'm going to be using a 1/4 inch end mill, so just make sure for this example that we specify 0.25 in there. And what this will do is leave a minimum of a 1/4 inch between any parts that are cut. We may wish to have a bigger clearance between any parts to preserve any cutting finishes that we apply when come to do the tool pass, that being either climb or conventional milling. If two parts were only a 1/4 inch apart, the diameter of the tool, when the tool will be cutting out one of the parts, it will also be cutting what would be the finish of another part. Or we may just want additional clearance to add tabs to hold our parts in place. So this is where the option for our clearance comes into play. So I may want to add an additional clearance onto the tool diameter of 0.35, so that we're going to have a maximum of 0.6 inches between parts that we're going to be cutting. This would mean the minimum gap between any tool paths that the tools may take. There would be a minimum gap of 0.1 inch in between each of the paths. That would be built up of two 1/4 inch tool paths. So if you imagine that there's a tool path going along this letter here, and then there's also a 1/4 inch tool path going on this letter here. The gap in between those tool paths, where the edge of the diameter of each tool will meet, there's going to be the gap of 0.1 inch in between there, which will then build up the 0.6 inch minimum clearance between the letters. The last option available to us within the tool and clearance settings is our border gap. Now this is the border or margin that's going to be applied to around the whole of the edge of our material, and for the purposes of the way we're going to hold the material down. So we may have clamps, or we may have screws that we've used to hold the material down. So for this I'm going to specify a border gap of 1/2 inch as I'll be clamping my material down. Now the next section, the part nesting options, is different methods that we can use to arrange our vectors that we've got selected in different ways to fit them better to allow more use of the available material. What I'm going to do to start with though is I'm just going to demonstrate what the results will be if we don't actually select any of the part nesting options, and it just nests them in the way that we're going to be selecting below, which is nest from and the nest direction. So the nest from is where we can select from either the bottom left, top right, or bottom right, and that means when the function is run, it will start nesting from that particular point. So at the moment it would start nesting from the bottom left. Now the next option where it says nest direction is whether it's going to nest from the bottom left and along X, which means it will first of all fill this side of X, and then it will start again all the way across the material that we've got, or then we've got the option to nest along Y, which will then fill from the bottom to the top. So I'm just going to keep these as the default at the moment. So I'll be nesting from the bottom left, and I'll be nesting along the X axis, and I'm just going to specify that I want a couple of copies of the vectors that we've got on screen. So what we do now is we click apply and then click to preview, and my initial instinct is that it's done a good job there, but what you may also not realise is that at the moment we've actually now got two sheets that now would be using to actually create the whole of these two copies. So in the 2D view, if we just zoom out a bit, you'll notice that we also have a sheet 2 where some of the letters that couldn't fit on this first sheet have now spilled over to a second sheet, which we would then need to machine on a separate piece of material. And we can change between these sheets by just double clicking in the grayed out preview. So if I wanted sheet 2 to be active, I can just double click on the sheet 2, and if I want to go back to sheet 1, I'll just double click there. We can also change the active sheet by using this drop down box here, so I could just select sheet 2 or go back to sheet 1. Now one thing you may realise also is the fact that we are going to be cutting out this centrepiece here. So this in effect is going to be waste material. So why not use that space to machine some other parts or products that we may also have in line as well. What I want to do here actually is to use this space to fill the rest of these letters into these. So how we do that is simply we reset our preview, and then we come up to the part nesting options, and we'll use this option here, which is allows parts inside other parts. And what this means is that the function is going to detect that this is going to be waste material, so then it will start nesting the other parts that we want to also copy inside that waste material. So now I've selected that, all I should have to do is simply click preview again, and we should then see that that space has now been taken up, like so. And you can see we've also been left with a lot more excess space. So we could also do a second job along with this one as well. It may be from the same customer. So I'm just going to go ahead and demonstrate this. So I'm just going to reset the preview and just come out of the nesting feature. I'm just going to turn on the other layer I've got. So just highlight that and just move that out the way. I'm just going to turn back on my original layer. And now what I'm going to do is I'm going to try and actually machine two copies of all of these jobs. So I'm just going to highlight all the vectors and go back into the nesting feature. And with all the same settings applied, I'm just simply going to go down, change the number of copies to 2, hit apply, and then preview. And you'll see that we're still on the one sheet, and we now have two jobs within the space of one sheet. We should then make this job very profitable, as now we're going to be maximising the use of the material that we've now purchased to produce this job. And what I can do now is I can simply apply a quick profile toolpath around these vectors, and I can demonstrate to you the tool diameter and the clearance gap between each of the parts, so you can get a better visual representation of what I mean. So if I just press OK to accept those changes, and then I go over to the toolpaths tab. Before we do any toolpaths, as always, we must check the material setup. So I can see that we've got a 1/2 inch thick material, the Z0 is off the top of the block, and our XY datum is in the lower left. Just check the rapid Z gaps and home start position, these all look fine, and just click OK. Now what I'm going to do is I'm just going to select all the vectors, and I'm going to go into Profile Toolpath. I'm going to start from the top of the material, and I'm going to cut to the full depth. So I'm just going to type in Z equals in the cut depth area there. I'm going to go into the tool database and select a 1/4 inch end mill. Obviously, if you're going to run this on your machine, do make sure that the speeds and feeds and cutting parameters are all specific to your machine before you go ahead and run anything, and just click OK. I'm going to select a machine outside the vectors here, and then I'm just going to scroll down, give this a name, profile cut out, and then just press to calculate that. I'm just going to go straight away and preview the toolpath. I'm just going to delete the excess material. And this will give you an idea of what the job will turn out like if you do go ahead and cut this. But what I wanted to show you was the actual gap between the toolpaths and the clearance that's actually available whilst cutting, just to demonstrate to you that they are not going to go too closely. So if we just turn on the toolpath and we go into the 2D view, the line that you can see with the arrows, that is the actual line. That is going to be the centre of the tool's diameter, and that's the path that the tool is going to take around all of the vectors. Now, if we actually turn on the solid preview down here, this will give you a solid outline of the actual tool diameter running around the outside of all the vectors. So, as you'll see, in between the two border shapes we've got here, you'll see that we've got a 1/4 inch diameter tool path going run through the outside of one border, and then just underneath it we've got the top profile cut of the second border shape. And you'll see in between this is going to be the excess material. This is the 0.1 inch I was talking about, which will be the minimum gap between the two toolpaths, which obviously you can then use for tabbing if you need to, or keep the toolpaths out the way for that, then they don't affect the finish on each part. So we're now going to move on to another example. So I'm just going to click close in the preview toolpath form, go back over to the drawing tab, and I'm just going to go to file and close. I don't want to make any save changes to that. I'm going to go back to open an existing file, and within the projects folder this time I'm going to select the nesting example.crv. So just highlight that and click open. You'll notice that we've got various different shapes along the right hand side of our work area. We are still working again with a material size of 48 inches by 48 inches. And the first thing we're going to try is we're going to try and get 25 copies of these vectors onto one sheet. So select these vectors and come over to the nesting icon and just select that. We're going to be using the same tool diameter, the same clearance and the same border gap as we did in the previous example. Again, just turn off all the options within the part nesting options, and we're going to keep the nesting from the bottom left and along X. I'm going to select to have 25 copies in this section here, and just simply click apply and then preview. Now you'll notice that we've managed to get 20 of these vectors onto the one sheet. We do have quite a bit of excess material left though on this one sheet, but if we zoom out we'll be able to see the sheet 2. So if I just double click on that, you'll see that we've now got the overspill from sheet 1. You'll notice that because we've got the nesting from the bottom left and along X, you'll notice that it's gone from the bottom left up, and then it goes to drop down again to the next row, and it will start from there, hence why we've got this one that's down the bottom here. So if we just go back to sheet 1, what we can do is we can demonstrate another way to nest these vectors. So I'm going to reset the preview, and with it selected still, I'm then going to choose the option to mirror parts to find the best fit. Now this may not be something that you may normally do, because most of the time material has a better top finish than it does a bottom finish. So the top of our part may always need to be in this direction. If we mirror the parts, obviously the bottom of our part is going to now be on the top of our material. So it may not be something that we may always want to do, but on parts where we're not that concerned about the finish on the top or bottom surface, this may be a good option to experiment with. So with the mirror parts to find best fit option selected, I'm now simply just going to click preview again, and you'll notice that it's again started from the bottom left and it's gone along X, filling trying to fill all the material as it can, and now it's got to a point here on 20, and it realizes that it can't then drop down again in X in the next row, and that's the point where the function will then decide to then use the option to then mirror the parts to find the best fit. So that's why you'll see that we've then got another 3 parts that have been mirrored in the space of what would have been, I suppose, waste material before we had the mirror parts selected, and it still had to then overspill 2 of the vectors onto another sheet. So we can see at the moment the mirroring parts hasn't quite worked out for us to get all the parts onto the one sheet. But what we can do is we can uncheck the mirror parts, and what we can do is we can try and rotate each individual part to try and get the best fit. So I'm going to select to rotate the parts, and I'm going to have a rotational step angle at 45 degrees. Now what this means is it's only going to ever rotate each of the vectors in 45-degree increments. Now you may want to specify a specific step angle, because you may have a certain angle that the grain on the material that you're using may have. So you may want to purposely choose a step angle so that the way that the material will be cut, it will always leave the grain facing in the one direction, so that you'll get a similar finish on all the parts. So I'm going to specify 45 degrees, and then I'm going to go down again and then click to first of all reset the preview, and then go ahead and then click the preview again. And this time you'll see that all the parts have been rotated, and it goes in a similar fashion. So it will start from the lower left and move along in X, and then it will start to alter the angle of each of the vectors to best fit within the material size. So as you can see, a 45-degree angle has still given us the ability to only fit 23 of these vectors onto the one sheet, and we've still got 2 which have overspilled onto a second sheet. What we can do though is we can reduce the rotational step angle if we're not concerned about the direction of any grain that we've got on the material, and we just want to make the best use of the material size that we've got. We can reduce the step angle to maybe have like a free rotation. So we could specify the rotational step angle to have a 1 degree step angle, so it can rotate each of these vectors up to 360 times using that 1 degree increment to find the best fit for our sheet. So I'm going to go down again, hit the reset preview button, and then to preview. And you'll notice that now we've got all 25 copies of the vector onto the one sheet, ready for machining with all our tool and clearance settings which have been abided to. So that just demonstrates how easy it is to actually get maximum usage out of the material that you actually have available. So I'm just going to go ahead and reset the preview, and now I'm going to try something different. So let's just imagine we've only got this size of material available to us, and for our next job all we've got to do is simply just create 5 copies of all these parts here. Now you might think that's really easy to do, and we can easily fit those onto this sheet, but what we wouldn't be doing is we wouldn't be making the most out of the space that we've got available to us. So my idea is we're going to nest the parts here so that we've got as much remaining space as possible for our next job that may come in whenever it does. So I'm going to highlight these vectors here, I'm going to go over to the nesting tab, and I'm going to choose all the same options that we had for our previous example, but this time I'm going to select to have 5 copies, and I'm just going to click apply and then preview. So what it's going to do, it's going to take all the options and it's going to then nest all the vectors that I had along the x-axis from the bottom left as tightly as it can along the left hand side of the material, like it has. So let's just press OK on that, and we're going to imagine that we've already ran this job on our machine, so that we're now left with just this material here. And what we can do is we can create our own material boundary. So we can just imagine that this is the actual file for our job that we ran, and now we're going to go ahead and run something different. So I've opened the same file, I've come in, I know that I've used this material here, so I'm just going to go ahead, just drag a box around the material. I can see that I've overlapped it slightly there, so I'm just going to just close this, select it, and just come over a little, just out the way of that. So I know that I've got roughly around about that amount of material left. And what I can do now is I can go ahead and go back into the nesting option, and I can first of all select the vectors for our new job, and then I can go ahead and hold shift down and then select what's going to be our nest boundary, and select that, and then make sure that this option is checked, and it will now only fill the area within our nest boundary with our parts. So if I just click preview, this is just giving us a warning because when we previously wanted to nest these vectors here, we wanted to do it 25 times, but I'm now going to change it to 5, so I'm just going to press yes to OK that. And you'll see that we have now made use of the material that was left over from our previous job, and we still have room for a bit more as well. So that just demonstrates how we can plan ahead with the jobs that we are given to maximise the usage out of every piece of material that we use. And this will allow for us to have greater profits in the long run. So I'm going to go ahead and just cancel this, and I'm just going to go to File and now close this file, as we're now going to move on to another example. So let's go to Open an Existing File, and for this one we're just going to open the widget vector.crv, so just highlight that and then press Open. Now this is a design that we created in a previous tutorial, And what I'm going to do is I'm going to demonstrate how we can then go ahead and apply toolpaths to this design to then plan ahead for the future in case we do at some point need to mass produce this or produce multiple amounts using the nesting feature. So what I'm going to do to start with is that I'm going to take the vectors, which I'm going to be using for separate toolpaths, and then putting them on their own layer. So the first lot of vectors that I'm going to group together are these rectangles, because these are going to be the rectangles that I then pocket. So I'm just going to hold Shift on the keyboard, and I'm just going to individually select each of these rectangles. And then what I'm going to do then, once I've highlighted them all, I'm just going to right click and then move to layer. I'm just going to select to choose a new layer. So I'm going to give that new layer a name, so I'm just going to call this recess rectangles. And I'm going to turn the layer off so it's not visible and it's not active, and just press OK, so that should then disappear off the screen. I'm then going to select our text, so just select it and then right click and then again move to new layer and just call this text. Again, turn the visibility off of that and then just press OK, so that then disappears off the screen also. Another way we can do this is we can first of all create a new layer, so I may want to go to the layers drop down, add a new layer, call this drill holes and then press close, and then what I can do is I can go around selecting all the circles that we've got that represent our drill holes on our part. And then again I can just right click and then move to layer, and this time you'll see that the layer, because we've created it or it already exists, it will be listed here. So I can just select drill holes and I'll then move that to the drill holes layer. And that now leaves us with one vector. So if I just go onto our layers and I'll just turn off all the layers, you'll notice that still there is one vector left on layer 1, that being our outline of our shape. So what I may want to just do, rather than moving this to a new layer of its own, I may just want to rename this layer to outline shape, as it only has that vector on it. So that's what I'm going to do. I'm just going to call this outline shape, and now I've got all of our vectors that represent a different type of toolpath on a different layer. So you may have already guessed why we've done that, but if not, all will be revealed. So let's just go over to the toolpaths tab and we can start creating our toolpath. So as we always do, before we create any toolpaths, we have to check our material setup. So I'm going to go into the material setup. I'm going to make sure that our material thickness is 0.375 of an inch. Z0 is off the top of the block, which is correct, and our XY datum position is starting in the lower left hand corner. Just make sure that the rapid gaps above the material are sufficient and our home start position is OK. And if we are OK with all those settings, just press OK. Now the first toolpath we're going to create is for our rectangles, and that's going to be a pocket toolpath. So I'm just going to deselect all my vectors and I'm going to go to the pocket toolpath icon. And I'm going to start our pocket from the top of the material, and I'm going to cut down to a depth of 1/8 of an inch. So I'm just going to type in 0.125 in there. Next I'm going to select our tools. I'm just going to open the tool database and select a 1/4 inch end mill. If you do plan on running this on your machine, do make sure that the cutting parameters and speeds and feeds are all appropriate for your own machine, and then press OK. For our pocketing strategy, we can use either an offset or a rastering strategy. I'm going to choose to have a rastering strategy with a cut direction of climb, and I'm going to choose to have a profile pass as well, and that's going to be on the last pass. Now you'll notice at the moment we don't have any vectors selected. Now I've done this on purpose because we're going to do an automatic selection. So the way we do this is we come down to this vector selection here, and you'll see at the moment it's on manual, so that means it's basically waiting for us to manually go ahead and select all the rectangles that we want to pocket, but I'm not going to do that. I'm just going to deselect all those rectangles, and I'm then going to click on the selector, and this will bring up this form. Now what I'm going to do is I'm going to specify some vectors which match this criteria here. So it says type of vectors to select, so I know that all my rectangles are all closed vectors, so I'm going to make sure that this option is checked, and then this radio button here is also checked as well. I can then move over to the right hand side, and then I can choose where I want the actual software to select my layers from. So I can either make it choose all closed vectors from all layers, which is not what I want, otherwise everything will be then selected apart from the text. So what I want to do is I want to select all closed vectors within a selected layer only, and that layer is going to be our recessed rectangles. And as you'll notice, as soon as I've checked that option there, all of the rectangles have become highlighted. And one last thing we can do now, and this is the clever part, is to associate these rules with this toolpath. So if I select this now, if I ever make any edits to this toolpath, or in the future I happen to want to create multiples of this one design, all I have to do is recalculate all the toolpaths, and it will find any new vectors that we've got on the recessed rectangles layer and then automatically apply this toolpath to them. So that's what makes this feature really handy, and that's why it's worth doing this extra step to plan ahead for the future, just in case we want to then make multiples of this one design. So with all that selected, I'm going to click close, and I'm just going to give this a name. So I'm just going to call this pocket rectangles, and then click calculate, and that's our first toolpath created. I'm not going to preview the toolpath just yet, so I'm just going to click close and then move on to the next toolpath. So I'm just going to bring up the 2D view, and then I'm going to go ahead and next I'm going to do the drill holes. So I'm going to select the drilling toolpath icon, I'm going to deselect any vectors that are currently selected, and I'm going to have a start depth from the top of the material, and I'm going to go the full depth of the material, so I'm just going to type in Z equals in the cut depth. For the tool, I'm going to choose from the tool database a 1/4 inch end mill, and then press OK. And I'm just going to go down the options. I know I don't want to use peg drilling, and I don't want to dwell at the bottom of each drill pass, and I don't want to use the vector selection order, as what I'm going to do again is I'm going to create an automatic selection. So just press the selector again. So I can go one step further this time as well, so I can go close vectors and then all closed vectors, but this time I'm out to select only circles. And within the only circles option, we have an option to select all circles, select circles matching a specific tool diameter, and then select circles matching and within a diameter and a tolerance value. But for this I'm just going to select all circles, as I know that there's only circles on this particular layer, so I'm just going to select drill holes within the layer selected and just deselect the rectangles, and as you'll see that all the circles are now highlighted. And again, I'm going to associate this selection with the toolpath, and then click close and just give this a name. So I'm just going to call this drill holes, and then click calculate, and you'll see that that's then applied that to the 3D and 2D view. Just going to deselect them all as we don't want to see them, and just press close, go back to the 2D view again. And the next toolpath we're going to create is the toolpath to etch in our text onto our widget. And what we're going to do is we're going to use a profile toolpath to profile with a VBit tool on to our vectors. So let's go ahead and go to the profile toolpath icon. Now if you remember, we pocketed out these rectangles to 1/8 of an inch deep, so our start depth will need to match that. So let's type in 0.125 there, and because we only want to finally etch in our text, we just need to specify a very shallow cut depth, so that just the point of the VBit tool will etch into the top surface of the material. So in the cut depth, I'm just going to specify a shallow cut depth of 0.03. Next, I'm going to show advanced toolpath options so that we can then have our vector selector. Otherwise, you'll notice that it's not actually available if we don't have that selected. And then we're going to move on to selecting our VBit tool. So let's open the tool database, and let's go to the VBit section, and I'm going to choose a 60° 1/4 inch VBit. Now obviously if you are running this, make sure these are all correct for your machine, and press OK. Now as this is single line text, we need to make sure that we're machining on the vectors to get the look that we want to achieve here. And then I'm just going to scroll down, and I'm going to go to the vector selection and press the button there. And I can choose here to choose open and close vectors, and I'm going to choose all closed vectors on the layer that is text. And as you'll notice that now only our text is selected from all the vectors on our screen at the moment. So with those selected, again tick the button to associate all this information with the toolpath and click close. And we can just give this a name, so I may want to just call this profile text and then click calculate. And then just close that again and go back to 2D view for our last toolpath. So our last toolpath is our cutout pass. So we know that's going to be a profile toolpath. So let's go to profile toolpath. We're going to start from the top of the material. So I know that I want to cut through the full depth of the material, so I'm just going to highlight the value and type in Z equals in there. I'm going to go into the tool database and select my 1/4 inch ml to do the cutting out pass, and then press OK. I know that I want to be machining on the outside of this vector, so I'm just going to select that option here, and then I'm going to scroll down and I'm going to go to the vector selection option, and I'm going to choose to only select closed vectors and only select closed vectors on our outline shape layer. So I'm just going to deselect the text layer so that only our outline shape is selected, and then again I'm going to choose to associate these options with the toolpath and then click close. And now that we've actually got a vector selected, we can now go ahead and think about how we're actually going to hold this part in place whilst we're cutting it out. So we actually may want to add tabs to this toolpath as well. And the good thing about this is that if we do go to nest this later on, the tabs will also be replicated as a part of this toolpath. So if I click to add tabs, I'm going to choose the length of our tabs to be 1/4 inch in length. So I'm just going to type in 0.25 there, and I'm going to keep the thickness of the tabs the same, so 0.05 inches. And then I'm going to specify where I want these tabs to be. So I'm just going to click on the Edit Tabs button, and if we wanted to, we could actually specify the software to automatically put in the tabs for us. So with the constant number of 4 there, we could just click to Add Tabs, and it will automatically add the tabs at equal spacing along the length of the outline. But that's not what I want, so I could manually drag these to where I actually did want them, or I could delete all tabs and just go ahead and manually input the tabs where I would like them. So I may want one there, I may want one there, and I also may want one down the bottom corner here. And when I'm happy with where I've got my tabs, I can just click close and then calculate my toolpath. So I'm just going to call this profile cutout and then click calculate. And that is all of our toolpaths calculated in a certain method that would be helpful to us later on if we do decide that we need to mass produce this part. And I will demonstrate the benefit of all this in just a moment, but first let's find out what we're actually working with. So I'm just going to first of all change the material to blue plastic, and then I'm going to preview the profile cutout. So just select that and press the preview, select the toolpath option. Then I'm going to preview the drill holes, and then I'm going to preview the pocket rectangles. So for this I'm just going to change it to a toolpath colour just to make it easier to differentiate, and I'm going to choose the colour yellow and preview that, and then I'm going to preview the profile text like so. And this is the part that we're working with. So we could go ahead now and just run this on a small piece of material just to create the one, or in the future if we needed to go ahead and mass produce this or create multiples of this one design, we could do so with ease. So let's demonstrate that now. So I'm just going to go over to the drawing tab and then select the 2D view, and then go back over into the job dimensions and origin and just change the size of material that we're working with. So I'm going to presume that I'm going to be creating multiples of this, and we're going to have a sheet size of 36 inches by 36 inches, and then click OK. Now it's warning us that we're going to have to recalculate all our toolpaths because the material size has changed. So let's press OK, and because we know that we're going to be recalculating all our toolpaths, we can rest assured that we know that we're going to be doing that. So let's select our vectors and go into the nesting option. So the first option is our tool diameter, so I'm going to be using on our profile pass. For this, we know that we're using a 1/4 inch ml, so let's just type that in there. The clearance for this, I'm going to specify as 1/2 inch, so just type in 0.5 in there. And for our border gap, we're going to have 1/4 inch, so just type in 0.25 in there. Now, I want to create 18 copies of this part. So I'm thinking that I might want to use the rotate parts to find the best fit. So I'm going to have a rotational angle of 90 degrees. So I'm just going to type 90 in there. And then I'm going to keep the nest from the lower left and nest along the x-axis selected. And I'm just going to select to have 18 copies and then hit apply. And you'll notice that all the vectors will have a number 18 next to them to represent that them are the ones that are going to be replicated 18 times. So once we've done that, let's press the preview button, and we've done okay. We've got 16 on our sheet, but it's not good enough as we do have a second sheet. So let's go back to our first sheet and let's reset the preview. And what we're going to do is we're going to lower the rotational angle to 30 degrees. So let's just change that to 30 and then press preview. And let's see how many we've got this time. Do we still have a sheet 2? We do have a sheet 2. But this time we've only got one that's spilled over to sheet 2. So let's go back to sheet 1 and then reset the preview. Now, something that we may actually want to reduce here is actually the clearance between each of the parts. So if we reduce this from half an inch to say 0.4 and then go ahead and hit preview, let's see if we've got all 18 on the one sheet. So let's just zoom out and you'll see that we've not got a sheet 2. So we've got all 18 on the single sheet simply by reducing the clearance in between each of the parts and reducing the actual rotational step angle. And because we calculated all the toolpaths in the way we did, all we need to do now is press OK to accept our nested parts, go over to the toolpaths tab and simply just recalculate all the toolpaths, and you'll find that we've now got toolpaths assigned to every single copy vector that we've just created. So recalculate, and let's go to the preview toolpath form and let's just preview all the selected toolpaths. And as you'll see, we've now got 18 individual widgets available to cut on our large piece simply by just adding vector selection whilst creating each of the toolpaths. So it's definitely a handy thing worth thinking about when creating any toolpaths that you may think that you may be using for that part in the future. So let's move on to our final example now. So I'm just going to go ahead and file and close this. And let's open our final file. So let's go to open an existing file and select the 3-leg stall.crv. Highlight that and then click open. So you'll see on screen that we've got our vectors for our 3-legged stall. And what we want to do is we want to create multiple copies of this again. But this time we actually might want to create them on multiple sheets. So first of all, let's highlight all the vectors and then come to the nesting option down the bottom. So I know that I'm going to be cutting this out with a 1/4 inch tool. So for our tool diameter, I'm just going to type in 1/4 inch there. And I'm going to add some clearance in between each of our parts. So I'm just going to specify 0.4 there. And for this I'm not actually going to specify any border gap, so I don't mind the actual edge of our parts touching the edge of our material. So I'm just going to type 0 in there as well. So out of this one sheet I reckon I can get about 3 copies of this stall. So let's just type 3 and click apply, and then I'm going to allow the parts to rotate at around 45 degrees. So that's the way I'm going to choose to nest these objects. So I'm just going to choose that option and then I'm going to hit the preview button. So I've managed to get 3 stalls onto the one sheet. Now if I actually wanted to have 6 copies of these, so then it would have to use multiple sheets of material, I could simply just reset the preview and then change the number to 6, click apply. You'll see all the numbers in the 2D view update. Then all we need to do then is hit the preview button, and then that will automatically update all the parts. So you'll see now that we've got 2 sheets, and on each of the sheets we've got different parts. So you'll see all the tops of our stall have been aligned first on the sheet 1, and then it's gone ahead and done the legs and the base parts on the rest of sheet 1 and then sheet 2. And to machine this is actually really simple. So if I press OK to accept all of this, we can just simply go over to the toolpaths tab, and as we know that to machine this, all we're going to do is simply create a profile cutout pass which goes through the full depth of the material. All we need to do is simply highlight all the vectors in one sheet, go to the profile toolpath option. We're going to have a start depth from the top of the material, and we're going to go through the full depth of the material. So just type in Z equals in there. Choose the appropriate tool. So we've already discussed that we're going to be using a 1/4 inch end mill for that. So I'm just going to select the 1/4 inch end mill and press OK. We're going to be machining on the outside of these vectors, and all we need to do now is simply scroll down, give this a name, so profile cutout. We're going to be imagining, by the way, that we're cutting this out on a vacuum machine bed so that we don't have to add any tabs to this. So just simply click calculate. And all we need to do now to calculate the toolpath for sheet 2 is duplicate this toolpath, go to the 2D view, select sheet 2, then double click on the actual toolpath we've just duplicated, and then literally just select these vectors and recalculate the toolpath using all the same settings that we've just done for the first one, and then click calculate. And you'll notice that if we preview these separately, that we'll have the individual sheet toolpaths ready to go. So let's just preview this. So this is the first one, so that's sheet 2. And if we preview sheet 1 now, so if I just reset that preview and choose sheet 1, and there we go, we've got sheet 1 all ready to go. And that now brings us to the end of all of our examples that we're going through to learn how to use the nesting feature. So I hope this has been useful, and thank you for watching.